Okay, so we're going to do number 9. It says order the following numbers from least to greatest. So again, we look at the first number, and then we just move our way to the right. Okay, so all of the first numbers are the same. Then we're going to look at the next number. Okay, so next I see there's a 1 here, there's a 2 here, 3. Okay, so from least to greatest, I know that the greatest number is going to be 7.3 because that one has a 3. Then next, so I'm looking at the second number. That's a 0, that's a 0, that's a 2. Okay, so then the 7.299. I'm kind of working backwards. Okay, I'm looking at the greatest number. Okay, so this one's out, and notice that I'm just going to cancel these ones out so I don't get confused. Okay, now this one has a 1, so that's going to be the next greatest number. So that one's out. And now I have to look between these two. So they both have a 0 starting off, but then the next number is a 5. See, this one's a 5, this one is a 0. So that means that this number is bigger than that number. So I'll put that one in. That's 7.05. So the least out of all of these is this guy right here. So 7.0008. So that's from least to greatest, smallest to the biggest number. That's how you do number 9. Okay, next it says find the sum, and we have fractions here. So in order for us to do fractions, we want to make sure that we have the denominators the same. Do you guys know what the denominator right now for 4 is? Yeah, it's 1. Okay, but what do we need it to be in order for us to add these? 7. So that means I'm going to go like this and leave the first one exactly the same, but the second fraction I want to change to be a 7. Now, how did I get from 7, or from 1 to 7? Excuse me. Yeah, so that means we have to multiply the top by 7 like we did earlier. So 4 times 7 is going to be 28. Then we just add. So 1 plus 28 is 29. 29, we leave the denominators the same, so it's going to be 29 over 7. Now we can change this to a mixed number. 7 goes into 29 how many times? 4, and then there's 1 left over. So over 7 like this. So the same one's going to be similar. Yeah, what's up?
If we leave it 29 over 7.
Okay, so you're saying is this wrong as opposed to this? Well, I think you guys need to be able to go from here to here, but then you should know that if this is your answer or this is your answer, both of these are equivalent. Okay? All right. All right, over here we have 2 different denominators, so that means we're going to have to find an LCD. What is the LCD between 5 and 4? 20, good. We're trying to find the least common number that they both go into. Okay? So 20 is the LCD. And just like what I did over here, I'm going to do on this one. So how do I get from 5 to 20? Good. So that means I have to multiply the top, so that's going to be 8. How do I get from 4 to 20? So I'll do that to the top as well. So that's 15. Now, is this going to be a party or war between these two? A war, right? Okay, because this is a positive, this is a negative. So who's going to win the battle, the 8 or the 15? The 15. So that means that our answer is going to be negative. And then we just subtract. What's 15 minus 8? 7. Perfect. Okay, so we've got negative 7 over 20. That's the answer for that one. All right, so this one's kind of confusing, but in the same time, it's also really simple. It says how many 1/5 are in 17 fifths? Easiest way that I could think to explain this is if you had 3 quarters, okay, like money. If you had 3 quarters, I asked you the question, hey, how many quarters are in 3 quarters? 3, right? 3 quarters are in 3 quarters. Okay, so here, how many 1/5 are in 17 over? So that would just be 17. Okay. All right, number 13, it says fill in the missing number that makes this equation true. So another way of kind of looking at this is just replacing that weird-looking box with just a variable. Okay, so if I had x times 4 equals 5 over 3. So now we just use our rules to get the x by itself. So how do I get the x by itself? How do I undo multiplication? Good. So if we divide both sides by 4. Now look, I'm going to change this up. Instead of dividing this by 4 and making it a complex fraction, I'm going to write it like this, divided by 4. Okay, that's the same way of doing that. So look, that cancels that out. So I have x by itself. Now on this side I have 5/3 divided by 4. Now 5/3 divided by 4, the technique that we learned is multiplying by the reciprocal. Okay, so you keep the first one exactly the same. Notice 5/3 is going to be right there. And we change this sign to be multiplication, and then by the reciprocal. Do you guys remember what the reciprocal of just 4 would be? Yeah, remember right now it's like this, so to do the reciprocal it would be 1 over 4. And then we multiply just straight across. So that's 5 times 1 divided by 3 times 4. So that's 5 over 12. Bingo. Okay, number 14. It says write the expression for each set of steps. So it says choose any number. What's a good variable to choose any number with? X. Okay, so it says X. Choose any number, X. Add 2. Then it says to multiply by 3. So with this number, after we add 2, we have to multiply everything by 3. So how can I represent that? Yeah, parentheses. So we put parentheses and then we put the 3 on the outside. Okay, let's try the next one. Choose any number, X. Multiply by 3. So I'm going to make it 3X. And then add 2. Bam. Choose any number, X. Subtract 2. Then multiply by 3. So here it's kind of the same as number 14. We have to multiply everything by 3. Okay, last one says choose a number, X. Multiply it by 3 and then subtract by 2. Okay, so there's 14 through 17. All right, insert the parentheses to make each equation true. So right now, 3 times 4 is 12. 12 plus 5 is not 27. So where can we put the parentheses to make this work? Good. Okay, so if we went like this and added these two first and then multiplied, see, that would be 9 times 3, which is 27. Nice job. Okay, what about here? Well, let's first just see if it adds up to negative 3. So this and this would give me negative 1. Here, I'll write it down. This is, I'm sorry, not negative 1, positive 1. Would give me positive 1. 1 minus 6, that would give me negative 5. And then negative 5 minus 2, that doesn't give me that. Okay, so where should we put the parentheses to make this happen? What do you think, Johnny? So if you put it around the 6 and the negative 2, it should work out. So we know that this is going to be positive 1. And then if we were to subtract these first, that would be 6 minus 2, which would be 4. And then it's got to be negative. So 1 minus 4 gives us the negative 3. Nice job. Okay, so around the 6 and the 2 would work out. All right, use the basic rules of arithmetic. Remember, this just means properties. To decide whether an expression equals the expression x plus 4y. So we have to see if this is going to end up equaling x plus 4y. So this is what I'm going to do. 2x, I'm going to look at all the x terms and I'm going to combine those. 2x minus x, that gives me x. Okay, so far we're on the right track. Then I'm going to do and then how many y's are over here? 2. So we got 2y plus 2y, that'll give me 4y. So this one checks. Okay, now this one I have to distribute, right? So that's going to be negative 2x, and that's going to be a negative times a negative will become a positive 2y. Okay, so I've got 2x and 2y right here. So 2y and 2y, that'll be 4y. But then if I have a 3x and a negative 2x, that still gives me the same x plus 4y. So this one checks out as well. Okay, here it looks like we have to distribute. So I'll do that one down here. 2x times x, that'll be negative 2x. Negative 2x times negative, that'll be positive 4y. Now I already see that there's going to be a problem. There's 1, 2, 3 x's here, so that'll give me that 1x that I need. But then I have an extra y right here that's positive, so that'll give me 5y plus 5y. See, so that one's a no good. Okay, last one, distribute, so that'll be 4x plus 4y, and then minus 3x. So if we subtract 3x from these 4x's, then we get the x plus 4y. So that one checks out in that one. Okay, so for this type of question, it'll say select all that apply. So all the ones that are red, those are the ones that you would be selecting. All right, 21 through 24, it says, describe one basic operation that you would use to transform this. So, I mean, you go from here to here. So notice that the 4x is still there, except all of a sudden the 6 is gone. That's next to it. So if we were to subtract 6 from both sides, we would see that that's what happened here. So we would write subtract 6. Okay, 22. What do we do? Well, the 4 went to 14, so does that mean that we just added 10x to this? See, that can't be true because you see how the 6 also changed? Yeah, it looks like we added 10 to everything. So how did they do that? Yeah, so if you did 10 to everything, so 10x, so add 10x and just 10 to both sides. All right, what about over here? How do we get from 4x to 16x? Okay, now let's see if that's consistent. If you multiplied this by 4 and this by 4, then you'd still get 48, so that's what's going on here. And then how do we get from 4x to 2x? Well, if you divide everything by 2. Okay, perfect. All right, number 25. It says evaluate the expression. So whenever you guys see the word evaluate, that just means substitute, then simplify. Okay, so here we want to take this expression, I'll rewrite it right here, 3 minus, and then instead of the t, we're going to put a value that they give us. So it says t equals 6. So if t equals 6, I'm going to put a 6 right here. Okay, and then follow the rules of PEMDAS to simplify. Notice there's no equal sign, so I'm not solving for t. This is just an expression that needs to be simplified. So 3 minus 6 is going to be negative 3. Negative 3 squared is 9. 9 minus 4 gives me 5. Okay? Same story, just different characters here. So we have 5 times 2k. Oops, hold on, let me change that up. I'll do it in black here. So 5 times 2, and then we'll leave a little space because we're going to put in a negative 3 here. Plus 1 minus 6, and then we'll put in a little space right here, and then minus 4, and then minus 10. So everywhere I see this little space, I'm going to put this negative 3, and then simplify. So it looks like I'm missing a set of parentheses around the 1 right here. Okay. So this times this is negative 6. Negative 6 plus 1 would give me negative 5. Negative 5 times 5, that'll give me the negative 25. Okay, now let's simplify this side. Negative 3 and a negative 4, that'll give me negative 7. Negative 7 times negative 6 will give me positive 42. And then I'm going to bring down the 10. Notice that the 10 is outside of the parentheses, so we're just going to bring it straight down, and it'll be right there. Okay, so what I would do is let's take care of, well, actually, couldn't I just go 42 minus 10 real quick to make that 32? Then we've got 32 is positive, and then the 25 is negative. So that means we're going to subtract. And when we subtract, we end up getting positive 7. Okay?